In last video we completed the final CNN fundamental tutorial. Now let's move towards the final hyperparameter tuning tutorial. I'll open it. Let me open it in the collab. Okay, so let's start with the cell one. In the first cell, I introduce the topic of hyperparameter tuning in deep learning. I explain what the notebook will cover, such as different tuning strategies like grid search, random search, Bayesian optimization. Also highlight why hyperparameter tuning is important for improving model performance. This cell sets the roadmap for entire notebook, and now moving forward, we will begin with our basic concepts. In this cell, I will install and import all the required libraries. I use NumPy for numerical operations, Matplotlib for visualization, PyTorch for building the models, and scikit-learn for dataset generation. I also import Optuna for advanced hyperparameter tuning. Then I suppress the warning and set the random seed for the reproducibility. Finally, I configure plotting settings so all the graphs are clean and readable. Now that the setup is ready, we move to the core concept. In this cell, let's move to the next cell. In this cell, I explain the difference between parameters and hyperparameters. Parameters are learned during training, like weights and biases, while hyperparameters are set before training, like learning rate and bit size. I also emphasize how much impact hyperparameters have on model performance. This builds the institution that tuning is critical. Now, to demonstrate this effect, I move to the practical example. Here, in this cell, I create a dataset using Mac moons and split it into training and validation sets. Then I define a simple neural network class using PyTorch. After that, I write the training functions that takes the hyperparameter like learning rate and hidden sizes. I train the model, track the both loss and validation accuracy, and then I finally plot the results for different learning rates, showing how performance changes drastically, and this clearly demonstrates the importance of hyperparameter. So now moving towards the key hyperparameter. In this cell, I list most important hyperparameters in deep learning. This includes the learning rate, batch size, and optimizers, model architecture choice. I also provide typical ranges, their expand impact levels. This help build intuition about where to focus during tuning. Now that we have what to tune, I move to visualizing and show how these parameters behave. In this cell, I visualize different hyperparameter effect. First, I show how learning rate has a sweet spot for best performance. Then I compare the batch size trade-off between the training speed and generalization. I illustrate the bias variance trade-off using model complexity. Finally, I show the relative importance of different hyperparameters. These plots help understanding tuning into intuitively. Now moving to the manual training strategy. So in this cell, I introduce manual tuning, starting with the learning rate finder concept. I explain how gradually increasing the rate helps identify a good range. If loss decreases, the learning rate is good. If it explodes too high, the this provides a practical heuristic. Now I move for the implementing of the idea code. Here I implemented a learning rate finder. I gradually increased the learning rate during the training and tracked the loss. I stop when the loss becomes unstable, and then I plot the learning rate versus loss on log scale. I also compute gradients to find the steepest descent point, which suggests an optimal learning rate. This gives a practical way to choose LR. Now moving to automated methods like grid search. In this cell, I explain the grid search. It tries every possible combination of hyperparameter from predefined list. It also shows how example grid and explain how combinations grow quickly. I discuss pro and the completeness and cons of high computational cost. This builds understanding and exhaustive search. Now I implement it in the code. So Here, I implemented grid search using iter tools product. I defined the function that trains the model with given hyperparameter and returns the validation accuracy. And then I loop over all combinations of learning rate, hidden sizes. I store results and print the accuracy for each configuration. Finally, I find the best combination. This shows how grid search works in practice. Now I visualize the result. So, uh, I visualized the grid search result using the heat map. I created matrix of accuracies for each combination of hyperparameter and then I use IM show to plot it. I label the axis with the learning rate and the hidden sizes. I also annotate the each cell with accuracy values, and this makes it easy to identify the best region. Now I move forward for efficient method called random search. In this cell, I explained why random search can be better than grid search. I highlighted that usually one of the few parameters matter most. Random search explores more unique values and important parameters. I also reference research supporting this idea. This builds motivation using random search. Now let's see it visually. So in this cell, I'll compare the grid search and random search. Visually, I plot the points between evenly spaced values. Then I plot random sampled space across the space. That shows random search covers more unique. Random search covers the more unique values of important parameters. This makes it more efficient in many cases. Uh, Now let me implement the random search. I implement the random search. I randomly sample learning rate, hidden sizes, and dropout value. Then I train the model for each trial and store results. I also print intermediate best result during the execution. I finally identified the best configuration found. This shows how random search explores space and now moving to the smarter method. In this cell, I introduced Bayesian optimization. I explained that it learns from previous trials to suggest the best hyperparameter. I described the concepts like surrogate models and acquisition functions. This method balances the exploration and exploitation. It is more efficient in than random or a grid search. Now I introduce the modern tool for it. In this cell, I introduce Optuna, a modern hyperparameter optimization framework. I highlight its feature like automatic pruning and efficient sampling. It simplifies the tuning process significantly. This prepares us to use it in practice. Now I implement Optuna optimization. In this cell, I define the Optuna objective functions and I use trial to suggest hyperparameters like learning rate, hidden sizes, dropout, and number of layers, and then I build a model dynamically based on these values. I train the model and evaluate the validation accuracy. I also use pruning to stop at bad trials early. Finally, I run multiple trials to find the best configuration, and this demonstrates the advanced tuning. Now I visualize the results. So in this cell, I visualize the optional result. I plot the optimization history to how accurately it moves over trials. Then I compute the parameter importance to understand which hyperparameter matters most. These plots help interpret the tuning process. This gives deeper insight into optimization. Now moving forward for the best practices. In this final cell, I summarize the best practices for hyperparameter tuning. I provide step by step strategies starting from simple steps to advanced methods. I also list common mistakes uh, to avoid during the training and where we can go wrong. And finally, I included a cheat sheet with practical guidelines. This acts as a quick revision and wrap up for the notebook nicely. Thank you so much.